Hey people, welcome back. In this session, we are going to learn about one-way ANOVA test. This is one of the popular statistical tests we use when you compare two plus data sets with each other. Basically, when you say two plus data sets, you have three or more than three. Suppose we take an example. You have, let's say, you are doing a production, and the production you are doing from the machines that you are running. So you have multiple machines. Suppose it's a machine one. You have, let's say, machine two. You may have machine three or machine four and so on. And you wanted to compare the production of all these machines with respect to the mean of that. Similar way, instead of production, maybe you have the teams and like team one, team two, team three, team four. Maybe you have vendor performance. Maybe anything else. Maybe you have in pharma, you have a medicine performance, different four type of medicine or five type of medicine, how they are reacting to the patients, that what we want to compare. So when we use one-way ANOVA, basically, we compare the average value of the data. So average of four machine, average of four team, average of four vendor or more than four vendor, or the medicine, average of the medicine response we wanted to compare. There are few conditions before we perform the one-way ANOVA. One, we will be performing the variances test, and according to the variance, we will check either the variance is equal or not equal. And we will be performing the normality test, and if the data is normally distributed or not normally distributed, according to that, we will be proceeding further. So one-way ANOVA need that your data should be normally distributed. An ideal condition, variances should be equal. If variances are not equal, still okay. We have the option in Minitab to select as a variance is not equal, but it's pre-assumed that you are comparing the mean, and mean we always compare for a normally distributed data. These are some conditions for the one-way ANOVA. So as I was telling, let's say I have some data. Maybe you have the teams. Suppose one team is sitting in the, let's say, city of Hyderabad. Maybe another team is sitting in Bangalore. Maybe the next team you have in Chennai, or maybe the another team you are sitting out of the Delhi. And now you want to perform the performance of these four teams with each other. So you will be having some data. Let me generate some data. Before I generate the data, let's understand what is the principal works behind the one-way ANOVA test. So suppose for each of the team, you will have some average value. Understanding the average value of your team one is somewhere here, let's say, and the average of the team 2 is maybe here, and team 2, team 3, and team 4 like this. Now, if you look mathematically and you look at these values, these four bar are different from each other. So we can clearly conclude that the average values are different. If these values, these lines are representing the average, and here is the average. But statistically, they may be same or they may be different, and it will depend all upon the confidence interval. So the confidence interval, when we compare confidence interval, we will get when you compare the mean value you have and you add plus or minus margin of error here. So mean plus or minus margin of error will give you confidence interval. So suppose these are the mean values, which is here, and you have the margin of error calculated for this data. And when you draw a plus or minus line, probably it may come like this. So this value may start from here. This may range from here to here, like this. Now, similar way, another value, assuming you take this second line, and second line is going from here to here, which is your blue line. So now if you look for the blue versus orange, at a point, they are overlapping with each other like this. Here is the confidence interval is overlapping. So whenever the confidence interval overlap, Statistically, they are same, and this is called as a null hypothesis. And if they does not overlap, this is called as an alternate hypothesis. If I take another example here for the green line, and you look from the green line perspective, this green line is overlapping with the blue line. So green and blue is statistically same because they are overlapping here. Blue is overlapping with orange. So blue and orange is statistically same. There is a null hypothesis. But if you compare the orange with the green, these two, nowhere they are overlapping because the range of the green is up to here on the lower side and the range of the orange is up to here on the upper side. And there is a clear gap created between these two. They are not overlapping. Green and orange is not overlapping. So I will say this will be the alternate hypothesis. So if you look from the two perspective, are they overlapping with each other? So actually they are not. At least one will be different when we look for the ANOVA test. In ANOVA test, at least one mean is statistically different from the others. So which one is different? Whichever is not overlapping with others, that is different. So in this case, orange and blue are same. Blue and green are same. Green and black are same. But black is different from the blue and orange. Blue is different from the black. And because blue is overlapping with green and orange is different from the green and the black because orange is overlapping with the blue but not with the green and black. That's how the basic principle of ANOVA test works. Now, similar way, if I generate the data in Excel sheet, let's say team one performance, if you look for the production perspective, they are doing the production around 20 to 26 transaction on an average per day. When I look for the team two, maybe they are doing the transaction from around 23 to, let's say, 27 transaction. If I look for the team three, they are doing, maybe they are much higher. Maybe let's say they are doing the 25 transaction to around 28 transaction. And the team four is approximately they are doing, let's say around 18 transaction to maybe around 28 transaction. Right? Now, I wanted to compare these four data set. Are they statistically same or they are different from each other? So I will be taking, let's say around 25 sample of all, each one of, and I will be pasting this as an value. Similar way as I was telling, the mean values of this data will be what? I can, if I calculate the average, mathematical average. So the average of this data set for the team 1 is around 23. Team 2 average is 24.92, team 3 average 26.5, and team 4 average is 22.92. We can say all of four values mathematically different from each other. But if I look for the confidence interval, I can tell you in the Excel as well, how do we calculate the margin of error. So margin of error, if you calculate, that will depend on the standard deviation and the number of sample. How many number of sample you have, and of course your alpha level, which generally we consider as in 0.05. So if I look for this, my standard deviation, if I calculate for this data set, standard deviation will be calculating with the formula is equal to stdev dot s. Here is my data. So standard deviation of this data set is 2. For the team 2 is 1.46, then 1.19, and the 3.90. Now the number of sample we know, we have taken 25 sample, but still let's count. So the number of sample for the team 1 is around 25, same 25, 25, 25, and alpha level we know 0.05 we are considering. Now I have got the required data, what I need to calculate the margin of error. So margin of error, if I want to calculate in Excel, I will be using the formula confidence.norm, selecting your alpha level, then standard deviation, and then number of sample 25, close the bracket. So my margin of error here is 0.78, this side 0.57, this side 0.46, and this side 1.32. For all the four values, I got my margin of error for teams. So my lower confidence interval will be mean value minus margin of error, and upper confidence interval will be mean value plus margin of error. So lower side, if I see mean value is 23 minus margin of error is this. So my difference will be around 22.22. So 23 minus 0.78 is 22.22. Now, if I look for the upper confidence interval, so upper confidence interval will be mean value plus margin of error. So this will be around 23.7. So basically, mathematical value 23 is statistically ranging from 22.22 to 23.78. This is the statistical range of this data, this 23. And similar way, if I copy paste this formula, I got the margin of error of all. So if we take an example, this 24.92 mathematically is statistically ranging from 24.34 starting to 25.50. Is this value is overlapping with this? You can clearly see if I make a graph of this and is 23.78 and this start is 24.34. So basically these two are not overlapping, because if I show you in a graphical way these two lines here, so team A is 22.22 is the starting point, where the average value is here, which was around 23, and end value is 23.78 is here, where the other one 24.34 start from here. So there is a clear gap between these two values, and they are not overlapping. That's how there is an alternate hypothesis for this data. And similar way we compare all. That's how it works. So now the same thing, I will help you how we can calculate the p-value in Excel as well as in the Minitab. So let me first tell you in the Excel for these four data set. We'll go to the data analysis. And now here you will see there is a ANOVA single factor or ANOVA two factor without replication, ANOVA two factor with replication. So we have a single factor only one thing we are comparing. So we'll select that ANOVA single factor. Now it is asking for the input range and grouped by the column. So these are the four different columns and these are my input range. I select this data from team 1, 2, 3, 4 till the bottom. Group by column because the data is in the different column and you have the label in the first row. Yes, team 1 and team 2. Alpha level 0.05. Output maybe I wanted to see here itself. Let's say on the same way in this column, I want to see the output of ANOVA. And that's all I'm done. I will just click on OK and my ANOVA analysis is ready. So ANOVA single factor, you can see the output here. You have the team 1, 2, 3, 4, total 25 sample, where the sum of the sample is coming this, and the average values is this, which exactly the same we calculated here. Now, based on this, F statistics is 15.54. Based on the F statistics only, will decide the p-value. And the p-value is coming less than 0.05. If I convert this value from general to number, this will be 0.00. And this is what my main thing which I will be looking for. P-value is less than 0.05, which means at least one average of the team is different from the other. Now, which average is different from the other? We can say wherever the confidence interval is not overlapping. So you see starting point 26.05, 26.99 is the ending point, which is completely different from the team 4, which is different from the team 2 as well, and which is different from the team 1. If I see here critically, so actually team 1 is overlapping with the team 4, and team 4 is overlapping probably with the team 2 partially. No, actually it's not. Team 2 is not overlapping. So only team 1 and team 4 are overlapping. Otherwise, team 2 are different from team 3. Team 1 is different from team 2 and team 3. And team 4 is different from the team 2 and team 3. Now let me show you the same data. How do we compare in Minitab? So I copy this data. I will follow variance. I will follow the normality of the data. So now I paste this data in the mini tab. First thing what we have to check the normality of the data. If data is normally distributed or not, I will go to the graph, probability plot, and in column, I'll select single because all the data is in single column. All the 4 data set I will be selecting here. Now, just in the multiple graph, maybe in separate graph or separate panel, where whatever you want to select, you can select, which is comfortable for you to interpret. Click on OK and we'll read the p-value. Now, if you see from this data, on the right hand side, there is a table created and here is the p-value. So p-value for the first data set is 0.022. Less than 0.05, data is not normally distributed. P-value for the second data set is 0.005. Again, less than 0.05, data is not normally distributed. P-value for the team 3 is less than 0.0505. Again, data is not normally distributed. And p-value for the team 4 is 0.07, which is little over than 0.05. So fourth is normally distributed. So you will see many times this situation when some data set are normal or some data set are not normal. In such condition, we treat our entire data set as a not normal data. So we know, considering the not normal data, if you wanted to go for the next, which is the comparing the test of equal variance, if data is normal, we compare with the Bartlett test you have seen in the previous session. And if data is not normal, we compare with the Levin's test. So normal, Bartlett, not normal, Levin's. So when we compare with the variance test, we'll go to the stat, ANOVA, and here is the test of equal variance. Click on this. Response of the data in one column, actually not, response is in the separate column. So I select this drop down and select all these 14. So how to select Bartlett or Levin's? You have to go to the options. In option, if you are used test based on the normal distribution, you check this box. It will assume the data as a normal and it will give you the p-value of Bartlett test. But if you leave this column blank, uncheck, Minitab will assume data as a not normal and it will give you the p-value of Levin's test. Because my data was not normal, so I'm leaving this uncheck. Click on OK. And here we go. Now you can see the p-value of the Levin's test is 0.00, which means variances are not equal. There is a difference and you can see the confidence interval of the variances, one or the other is not overlapping with each other. Example wise, the team 3 is starting from 1.0 to 1.57, while the team 1 is starting from 1.62 going up to 2.78. So the lower point, which is 1.57, and the starting point 1.67, there is a clear gap is created, which means this 1 to 1.57 is here and 1.62 to 2.72 is here, and this is the clear gap created between. Whenever the gap is created in the confidence interval, it's a alternate hypothesis. And you can see the same thing here as well. Like as this value, fourth value is completely different from 2 and 3. And if I see this at point 2.51, maybe I draw a line here at the 2.52, right click, edit, and add item, let's say on the x-axis level. And what should I do? Reference line, x-axis 2.52, just to show you more clarity. And I click on, sorry, I did mistake, y-axis, reference line 2.52. Yep, now you see. So this line is 2.52 is created, and actually the team 4 is completely different from 1, 2, and 3. All 3 it is different. And any one is different, that's the alternate hypothesis we can see. So variances are unequal. So when I perform ANOVA, I'll go to stat, ANOVA, and one-way ANOVA analysis. Again, data is in separate column 1, 2, 3, 4. In options, the assume equal variances that commonly you have, you will uncheck this box and then proceed. because my variances are not equal. Ideally, I should not be performing the mean as well here because my data is not normally distributed. In this condition, we perform either Moore's median or Kruskal-Wallis test. But suppose your client is not agreeing, client is telling, I am not worrying about normality or not normality. I want my average value to meet. So with the precautions, you can proceed with the average comparison and uncheck this assume equal variances because variances was not equal. Click on OK. Click on OK. And here is the result of ANOVA. So what ANOVA in the model summary? This is giving you the confidence around 30.6%. Here is your confidence intervals of the average value of each team. And this is the graphical representation, like average value is 23 for the team 1, ranging from, here you read the confidence interval 22.17 to 23.86, 826. Average of the second team is around 24.92, which is ranging to 24.31 to 25.52. Average of the team 3 is around 26.52, ranging from 26.02 to 27.013. And average of the team 4 is 22.92, ranging from 21.52 to 24.31. This is the way we'll be reading the ANOVA. And if you look at the p-value of the Welch test, here the p-value is less than 0.05, which means there is a clear difference in the mean values of these 4 teams. This is the way I explained you about in what condition we do the ANOVA analysis. I explained you about what is the principle that work for the ANOVA analysis, how the overlap will see, what are the number of sample, basic assumption about the normality and the equivalence, and then we proceed with the ANOVA test. Thank you so much, people, and I'll see you in the next session.